has Curiosity discovered anything which suggests that Mars could have supported actual life?
One of the wonderful things about this mission is that before we were halfway done with what we call the prime mission, we'd already taken data that told the scientists that, in fact, ancient Mars.
Well, cast your mind back to February last year and you may remember the excitement when NASA successfully landed its Perseverance Rover on Mars. Well, it's been busy for the last 15 months or so, doing plenty of roving, and now it's ready for the most important part of the mission, searching for signs of life. Our science editor, Rebecca Morrell, has the details.
NASA took an unprecedented risk, lowering a giant robot onto Mars using a sky crane. A single error could have led to catastrophe. Yet against all odds, Curiosity landed flawlessly, making space history. It uncovered evidence that Mars once had water, rivers, lakes, and environments that could have supported life. But the biggest surprise? It detected methane, a gas often associated with life on Earth. Stay tuned. This mystery is only getting more intriguing. How NASA landed a rover like never before. Curiosity's landing wasn't just another space mission. It was a bold gamble. Scientists at NASA's Jet Propulsion Laboratory ditched traditional methods and went all in with a never-before-tested sky crane system. Picture a hovering platform jet firing like a tiny spaceship, lowering a massive rover gently onto the Martian surface with cables. The risks were sky-high, but when Curiosity landed smoothly in Gale Crater, it was a victory like no other. And that was just the beginning. As Curiosity traversed the Martian landscape, one discovery would challenge everything we thought we knew about the red planet. Gale Crater wasn't just another dusty depression. It was a gateway to Mars' ancient past, a geological time capsule preserving its secrets in layers of rock. At its center loomed Mount Sharp, a towering peak rich with history. The lower strata contained minerals formed in water, undeniable evidence that Mars was once home to lakes and rivers. As the layers ascended, they painted a picture of the planet's transformation from a watery world to the cold, barren terrain we see today. For scientists, Mount Sharp was a treasure trove of knowledge, and Curiosity was the key to unlocking its mysteries. The moment Curiosity hit the ground, it got straight to work. It started snapping photos, checking its instruments, and exploring its surroundings. The worry that Martian dust might mess up its gear turned out to be nothing. Everything worked, and Curiosity was ready for adventure. One of its coolest tools was a laser-blasting gadget called ChemCam. It could zap rocks and read the light that bounced off to figure out what they were made of. The first test was on a rock named Coronation, and the laser was so hot it could outshine the sun's surface for a split second. Curiosity did more than just fire lasers. It drilled into rocks, collected soil, and even heated samples in its onboard oven. One of its most intriguing discoveries? Methane. Not much, but just enough to spark curiosity. On Earth, methane is often linked to life, whether from underground microbes, livestock, or decaying plants. But on Mars, its source remains a mystery. Could it be traces of ancient life, or is it simply a quirk of a planet's chemistry? Either way, this unexpected find challenged scientists to reconsider what they thought they knew. As Curiosity climbed higher, it kept finding more proof that Mars once had lakes and rivers. Imagine a planet where water once flowed freely, filling ancient valleys and leaving behind clues in the rocks. Billions of years ago, Mars might have been a place where life had a shot, not little green men, but tiny microbes. Creatures that thrive in Earth's most extreme environments helped scientists envision a once vibrant Mars, thanks to Curiosity. But the rover's journey was anything but easy. Mars took a toll on its wheels. Jagged rocks ripped through them, causing cracks and holes. Engineers had to adapt, adjusting its movements, mapping out safer paths, and ensuring it kept going well beyond its initial mission timeline. Originally designed to last just a few years, Curiosity defied expectations, continuing to explore and uncover new findings. Even before launch, NASA subjected the rover to intense testing. Engineers pushed it through extreme trials to ensure it could endure Mars' harshest conditions. Parachutes were tested at breakneck speeds, radar systems were flown over Earth's Mars-like deserts, and every component was inspected, re-inspected, and tested repeatedly. When the moment of truth arrived, all that preparation paid off. While the hunt for life is fascinating, Perseverance isn't just about looking backward. It's also testing tech that could be crucial for future human missions. Take MOXIE, for example, a clever device that turns Mars' carbon dioxide-rich atmosphere into oxygen. Yes, you heard that right. Perseverance is literally making air on Mars. This is a huge deal because it shows we might not need to haul tons of oxygen from Earth when humans finally set up camp on the red planet. Perseverance's journey has been anything but easy. Mars presents extreme challenges, from frigid temperatures and fierce dust storms to rough landscapes that would test even the most rugged SUV. Yet, this rover was designed to withstand it all. It has tackled rocky obstacles, maneuvered steep slopes, and endured conditions that would cripple most earthly machines. Each day it operates on the red planet is a tribute to the incredible engineering behind its creation. Then there's the matter of communication. It's not like Perseverance can just pick up a phone and call home. Signals from Mars take anywhere between 5 to 20 minutes to reach Earth, depending on the planet's positions. This delay means the rover has to be pretty independent, using onboard computers to make real-time decisions about where to go and what to do. It's like giving a robot the freedom to explore a whole planet, a mix of thrilling and nerve-wracking for the scientists back on Earth. One of the most thrilling parts of Perseverance's mission is its involvement in the Mars Sample Return Project. NASA and the European Space Agency are working together to retrieve the sealed tubes containing Martian rock and soil. The plan involves sending another spacecraft to Mars to collect these samples and bring them back to Earth by the early 2030s. If successful, these samples could help answer some of the most profound questions about Mars. Did it ever support life? What can its geology reveal about its past? And perhaps most intriguingly, what does this mean for the possibility of life beyond Earth? Perseverance's impact extends beyond just science and technology. They've captured the public's imagination. People around the world have followed its path, cheered for Ingenuity flights, and marveled at the stunning images and sounds sent back from Mars. It's a reminder that even in a world full of challenges, humanity can still achieve incredible things when we aim for the stars, or, in this case, another planet. As Perseverance continues its mission, it's paving the way for the next era of exploration. Its data will guide future missions, whether robotic or human, and help us prepare for the monumental task of living on another world. Whether it's finding traces of ancient life or testing technologies for survival, this rover is setting the stage for humanity's next giant leap. And who knows? Maybe one day, humans will stand in Jezero Crater, looking down at the tracks left by this remarkable machine and thinking about how it all started. As Perseverance continues its discoveries on Mars, the planet remains full of mysteries that baffle scientists. One intriguing puzzle is the magnetic traces Mars has left behind, reminders of its strange and unpredictable nature. Among the biggest questions is methane. On Earth, this gas is typically linked to life or geological activity, but on Mars, its origin remains uncertain. Adding to the mystery, methane levels fluctuate unpredictably, almost as if the planet is dropping hints. Some scientists speculate that hidden microbial life could be responsible, while others point to natural chemical reactions. Yet, without a definitive answer, the enigma of what lies beneath Mars' dusty surface remains unsolved. Then there are those strange plumes that were spotted back in 2012, rising 155 miles above the surface. They're way too tall for typical weather patterns. Dust storms? Maybe. Auroras? Possibly. But no one's nailed it down. Whatever's causing these sky-high phenomena, it's definitely not normal, and it's raising eyebrows about Mars's atmospheric quirks. Speaking of weird, let's talk about the so-called spider formations found in the southern regions. These creepy web-like shapes appear when carbon dioxide ice sublimates, carving out strange channels in the dirt. It sounds simple enough, but the exact process still isn't fully understood. What's causing the ice to behave this way, and why only in certain places? The answers remain elusive, And these spider-like patterns are just another reminder that Mars likes to keep its secrets. Mars seems to have a split personality. Its northern hemisphere is a vast expanse of smooth plains, while the southern half is rugged and cratered, as if two different worlds were fused together. Scientists believe a massive impact billions of years ago could be responsible, but solid evidence remains elusive. If such a collision occurred, why hasn't more proof surfaced? It's as if Mars' history is encoded in a mystery we have yet to decipher.